Hello guys, in this video I'm gonna show you how to simulate a multiplexer circuit in Multisim. So we start first by explaining or demonstrating what is a multiplexer. So a multiplexer usually have like more input than the output. Okay, so in this case, for example, we have here we have actually 4 inputs here and 1 output. Okay, we're gonna neglect the enable input for now. I'm gonna explain what it does in at the end. But basically, we can concentrate on these 3 inputs here. Okay, one of them is called the control input, usually called selector or selection, and the other ones are data for data. Okay, so what it does exactly, when this selector bit is 0, the output here will copy the input 0, data input 0. Okay, the one in the top here. And when the selector is 1, the output will copy the value of data input 1. For example, if the selector is 0, okay, so data output should equal to data input 0. So if data input 0 has a 0 here, there will be 0 at the output. If there is 1 here, there will be 1 at the output. If selector is 1, then the output here will copy data input 1. So if there is 0 here, there will be 0 here. If there is 1 here, there will be 1 here. Okay. So finally, what is this enable input does? It basically enable or disable the circuit. So if it's 1, for example, then the circuit is usable. You can use it. So if you put the selector is 0, for example, and there is like 0 in input 0, then there will be 0 at the output. If there is 1, there will be 1 at the output. Like the normal operations that I just explained. But if enable is 0, which means disable the circuit, you're gonna find the output usually have like constant value. It doesn't change with the input, whatever the selector is. And that means the circuit is just disabled. It's not working. Okay? And sometimes this is useful. So the truth table for the 2x1 multiplexer is like that. Okay? So you have, like, it's called the 2x1 multiplexer because you have 2 data inputs. But although you have overall you have 3 inputs because the selection is input as well. So you have 2 data inputs and 1 control input. But overall, to design the circuit, we have to consider the 3 inputs, the data and the control. So here, since there are 3 inputs, we have 8 states from 0, 0, 0 until 1, 1, 1. Okay. And as you see, guys, here in the first 4 states, we have zeros in the selection. So the output Z copies the 0 exactly. Like the first 4 here, we have here 0, 1, 0, 1. Then in Z, we have 0, 1, 0, 1. The second 4 states, we have 1. So Z should copy D1. And look here, D1 is 0, 0, 1, 1. And the output Z is also 0, 0, 1, 1. Okay. How basically from the truth table we go and find a circuit, we use Logisim. Okay, so I explained before in a previous video how to download and install Logisim. It's free. Okay, so just to go back to this video and this playlist, and you can find out more about that. But anyways, in this tab input, we put the inputs, and it's good to put them the same order like this: S0, D1, D0. Like that. S first, then D1, then D0. Because once you do this, and of course the output is Z, because the truth table will be exactly like what you have here. So you don't confuse yourself, because if you switch the order, the truth table will be different. Okay, although it's correct as well. And as you see, guys, here 0, 1, 0, 1, 0, 0, 1, 1, just like what we have here. Okay, and how to input any, like we just toggle. You see, we put here the zeros in the output here. We just click, it will change. Of course, the input here, this is like that is fixed, because 3 inputs means like 80 states. From 0, 0, 0, you can't change this until 1, 1, 1. Okay, the output you change by yourself because this is your design. So you just toggle. Okay, then here is you click build expression, it will generate the expression for you. Okay, After having the equation, now it's time to simulate this equation in or implement this equation in multisim. So today I'm gonna use like a new way to add like logic circuits into multisim. So we can place component and we can choose here master database and all groups and just hit or. It's gonna give you or gate. Okay, that's an or gate, for example. If we need an AND gate, same stuff. So, and yeah, we need just AND with two inputs. We need just two of these. And we need inverter. For inverter, we write not, I believe. Yes. And that's for S, for the selection. And we don't need more. Okay. So we know that the outputs of the two AND gates will go to the OR gate. We know that the S bar will be input to one of the AND gates. So the input here should be S. The output here should be Y, D0. And we know also that S should connect to the second input AND gate. The second input of the AND gate. So we should put here D0 because this is S bar. And with S, we should put D1. Okay. And this is the output Z. So now to simulate this easily, we use the logic converter. It will should be on this menu here on the far right of multisim. Just hover over each icon until it appears to you. This is the logic converter. The far right goes to far right bin of the logic converter goes to the output, and the far left will be the inputs. Okay, so we have S0 here, should be connected to this, then D0 or D1, then D0. Okay. Now to simulate, we just hit run and wait for a few seconds and stop. Double click on the logic converter and press the conversion here, the first one, converting the logic circuit into the truth table. We should get this truth table. Yes, we got it, exactly. Okay, so as you see, guys, here, A is considered the S, B is D1, C is D0. And as you see, the order matters, you know. Then the output, as you see, 0101, 0101, then 0011, like here, 0011. Okay, guys, just take a screenshot of this and submit the report. Thank you very much for watching and see you in another video. Bye-bye.